Okay, so let's do number 5. Consider the parametric curve described by the equations x is equal to t squared minus 6t, y is equal to t cubed minus 12t. Find the point or points on the curve where the tangent line is horizontal or vertical. Okay, so what we're going to do, so we derive the expressions with respect to t, and then we find the values of t where they are where the derivatives are 0. Okay, so we have dx over dt is equal to 2t minus 6. So we can factor out 2 times t minus 3. So we know that dx over dt is equal to 0 when t is equal to 3. And then dy over dt, now this is 3t squared minus 12. So again, factor out 3 times t plus 2 multiplied by t minus 2. And so we know that dy over dt is equal to 0 when t is negative 2 and positive 2. Okay, so now to find the values of t where there will be a vertical tangent line, dx over dt should be equal to 0 while dy over dt is not equal to 0. Okay, so in here, so since the values for t that will make dx over dt and dy over dt is equal to 0 are different, then we just have to take the values of t where dx over dt is equal to 0, so which is t is equal to 3. Okay, so let's just plug in. So we have for x, so that's t squared minus 60. So we have 3 squared minus 6 times 3. So that's 9 minus 18, negative 9. And then 3 cubed minus 12 times 3. So we have 27 minus 36. So that's negative 9. So next, for the horizontal, so dx over dt cannot be equal to 0 and dy over dt is equal to 0. So we just need to plug in the t's that will make dy over dt equal to 0. So we have t is equal to negative 2. Okay, so let's plug in. So you have negative 2 quantity squared minus 6 times negative 2. Negative 2 quantity cubed minus 12 multiplied by negative 2. So that's 16. And t is equal to 2. Again, so we have 4 minus 12, that's negative 8. And then you have 8 minus 24, that's negative 16. Okay, so therefore the curve has a vertical tangent line at point negative 9, negative 9, and horizontal tangent lines at 16, 16, and negative 8, negative 6. Okay, so in case that you will be encountering dx over dt and the values of t that will make both dx over dt and dy over dt to be equal to 0, then you need to use the limit formula. And in here, I just picked those t's that will make the derivative 0, only because I know that these values of t will not make the other derivative 0. Okay, so just be mindful. So next, number 6, consider the parametric curve described by the equations x is equal to 2t plus ln t, y is equal to 2t minus ln t. Determine the t intervals on which the curve is concave up. Okay, so now we have expressions that involve polynomials and logarithmic functions. So in here, this already gives us a restriction for the t interval. What we know that the logarithmic functions or expressions can be functions only when t is in the interval 0 to positive infinity open. So you will just be restricting t there. Otherwise, ln t becomes imaginary, so or undefined. So yun, so we will just be considering the values of t that will make ln a real number. Okay, so again, since we're dealing with concave up, so we're dealing with second derivative, so at least first look at the derivatives. So dx over dt, so that's 2 plus 1 over t. And then again, let's look at the values of t, where dx over dt is equal to 0. So let's rewrite everything in one fraction. So that's 2t plus 1 over t. So this becomes 0 when 2t plus 1 is equal to 0. So that's when t is equal to negative 1/2. But then since we're going to restrict t to positive real numbers, then we know that dx over dt cannot be equal to 0. So for all the valid values for t. Okay, and then next, we have dy over dt, so 2 minus 1 over t. So that's 2t minus 1 all over t. Okay, so this becomes 0 when 2t minus 1 is 0. So that's when t is equal to 1/2. Okay, so since we're dealing with second derivative, then we need the derivative, dy over dx. So we need to show that the curve is smooth. So again, we check if dx over dt and dy over dt are continuous on the given interval 0 to positive infinity. So yeah, the only way or the only time that these expressions are not continuous on the zeros of the denominator, which is 0. Since it isn't in the interval, then that means that they are both continuous. Okay, and then never both zeros. In fact, dx over dt is never 0. Okay, so that means that the curve is smooth in the t interval 0 to positive infinity. Open. Okay, so now let's compute for the first derivative, dy over dx. So that's dy over dt over dx over dt. So you have 2t minus 1 all over t over 2t plus 1 all over t. So you have 2t minus 1 over 2t plus 1. So you can just cancel out because t is never 0. So again, just be mindful about canceling variables. Make sure that they will never be 0. Okay, and then I'll just rewrite this in terms of 1 minus 2 over 2t plus 1, mainly because this is easier to derive, as compared to 2t minus 1 over 2t plus 1. Okay, let's move on. So now let's compute for the double derivative. Okay. We notice here that there's no change on the t interval. I didn't exclude anything because dx over dt is always not equal to 0. Okay, so let's proceed. So d squared y over dx squared, that's just the derivative of dy over dx with respect to t all over dx over dt. Okay, so just plug in derivative of 1 minus 2 over 2t plus 1 all over 2t plus 1 over t. Okay, so let's derive this. We can just do just individually derive this 2. So derivative of 1 is 0, and then this one you can think of it as negative 2 multiplied by 2t plus 1 raised to negative 1 power. So you can use chain rule. So you have 4 over 2t plus 1 quantity squared all over 2t plus 1 all over t. And then just simplify, you have 4t over 2t plus 1 cubed. And again, looking at the interval 0 to positive infinity. So you see that the numerator and the denominator are both positive, so therefore greater than 0 for all t in 0 to positive infinity. So since the second derivative is always greater than 0, then we know that the curve is concave up in the interval. Okay, so for the last item, find the length of the arc of the parametric curve described by the equations x is equal to square root of 3t squared, y is equal to 3t minus 1/3 t cubed in the interval negative 3 to 3 inclusive. Okay, so again, let's derive. So we want to show that the arc is smooth, or the curve is smooth in the interval. So let's derive. So 2 square root of 3t, and so this derivative is equal to 0 when t is equal to 0. And then we have dy over dt, so you have derived, so 3 minus t squared. And then we can rewrite this as negative t squared minus 3 ng quantity, so which is a little bit similar to difference of two squares, except that 3 is not a square. So we will just rewrite it as a square root number. So we have negative t plus square root of 3, and then we have t minus square root of 3. And so dy over dt is equal to 0 when t is equal to negative 3, square root of 3, and positive square root of 3. So these two numbers are both in this interval. Okay. So now, okay, so definitely both derivatives are continuous, in the interval, since we have polynomials, so definitely they are continuous everywhere. And when you look at the values of t, that makes the derivative 0, all of them are mutually exclusive, so I know that they are never both 0 in the interval. And so the curve is smooth in the t interval, close interval, negative 3 to 3. Okay, and then let's use the formula for the arc length, and then let's first define L to be the length of the arc. So we have the formula L is equal to, so the integral of square root of quantity dx over dt squared plus quantity dy over dt squared dt, so evaluated from negative 3 to 3. So let's plug in. So you have 2 square root of 3t squared plus 3 minus t squared. So I kept the original derivative form since it's easier to square and expand. Okay, so let's simplify. So you have square root of quantity 12 t squared, and then so binomial expansion, so 9 minus 6t squared plus t to the fourth dt. And then let's simplify. So that's t to the fourth plus 6t squared plus 9. So you see this is a perfect square trinomial. So this is t plus 3 squared, t squared plus 3 squared. And then when you square root, so you take the positive root, so positive square root. So let's first write it as absolute value. So t squared plus 3, so absolute value. And since the expression is composed of a squared number and a positive number, then definitely t squared plus 3 is always non-negative for any number in this interval. So that means that when I evaluate the absolute value, it's always positive, so I can just get rid of the absolute value. So you have the integral of t squared plus 3 dt evaluated from negative 3 to 3. Okay, so let's integrate. So you have t cubed over 3 plus 3t evaluated from negative 3 to 3. So you have 3 cubed over 3 plus 3 times 3 minus negative 3 cubed over 3 minus 3 times negative 3. Okay. So we have 36. No? So this is 9 plus 9. This is again 9, 9. So we have 36. So the length of the arc is 36 units.